In this video, we're going to be thinking about what composes a buffer and how the composition of that buffer changes as the pH changes. Okay, so we've actually discussed this indirectly a number of times so far. Let's introduce the idea in the context of our titration curve. Right, so we know on the y-axis we have pH. On the x-axis we know that we are increasing the concentration of sodium hydroxide, which ultimately we know is reacting with the acid form of our buffer. Right, so we have our acid form reacting with hydroxide to make the base form and water. So at the very beginning here, we know that we start with HA, and as we progress through our half equivalence point up to our first equivalence point, so here we have our equivalence point, what we know is true at this point is that 100% of our acid has been converted to our weak base. So we have 100% conversion. Okay? That's what's true at the equivalence point. At the half equivalence point, right, so here is our half equivalence point, then we have exactly 50% of our acid being converted to the weak base. So we have 50% conversion. Okay, and so these ideas are really, really important to keep in mind. So at the beginning of the titration, we have 100% HA. At the equivalence point, we've converted all of that acid, and we now have 100% of the basic form. And in the middle, we have 50% of the acid form and 50% of the basic form. So 50% of our buffer is comprised of the base and 50% is comprised of the acid. So what we can do is we can actually put this idea in the context of what's known as a speciation curve. So on the y-axis, it's going to be relative abundance. So at the very top here, we have 100%. In the middle, we have 50%, and at the very bottom is 0%. Okay? And then the x-axis here is going to be exactly the same as what we see on a titration. So we have a half equivalence point, and we have a full equivalence point. Okay? So what we're going to think about then, what we're going to plot is, let's say in pink, we're going to plot the concentration of our acid form, and then in green, we're going to be plotting the concentration of the base form. Okay? So let's think about this from the perspective of our titration first. We know that at the beginning of this reaction, we start with 100% HA. So let's plot that on our relative abundance curve. At the beginning of the reaction, we have 100% of our acid in the form of HA. By the time we've reached our half equivalence point, we now only have 50% of our buffer in the form of HA. So the concentration of HA has dropped to 50%, and by the time we've reached our equivalence point, we've converted all of our acid into a base. So now the concentration of our acid is 0. So 0% of the buffer is present in the form of the acid. So if we plot this then, what we can kind of see is this downward trend moving through the half equivalence point down to the equivalence point. So the concentration of our acid form of our buffer decreases as we progress through our half equivalence and our equivalence point. Okay? Let's think about what's happening with the base form now. So at the beginning, we have 100% of the buffer in the form of the acid, meaning that we must have 0% in the form of the base. Once we reach our half equivalence point here, we know that 50% of it's been converted to the base. So we have 50% in the form of the base. And then by the time we've reached our equivalence point, 100% of the buffer has been converted to our base. So now at the equivalence point, 100% of the species is present in the basic form. So this curve is really inverted compared to the acid. We increase concentration through, so we reach 50% at the half equivalence point, and we reach 100% at the equivalence point. Okay? Let's take a second to think about what this speciation means in the context of our pH. We know that the titration curve goes through the pKa at the half equivalence point, and then we have a sharp transition at the equivalence point. Right? So at the half equivalence point, we have our pH equal to our pKa. Okay, so let's focus then on the half equivalence point. Okay, from our titration curve, we know that at this point, pH equals pKa. And from our speciation curve, we know that at this point, the concentration of the base equals the concentration of the acid. Okay, so from our titration curve, we can see that anytime we are to the left of the half equivalence point, so anytime we have not reached the half equivalence point, our pH is more acidic than our pKa. So when the pH is less than the pKa, that comes before the half equivalence point, and based on our speciation curve, at all of these points, we see that the concentration of the acid form of our buffer is greater than the concentration of the base form. So whenever the pH is more acidic than the pKa, the concentration of the acid form of our buffer is greater than the concentration of the base form. The opposite's true when the pH is greater than the pKa. So anytime we're past the half equivalence point on our titration curve, we see that our pH is greater than our pKa. And on our speciation curve, we can see that anytime we're within this range, the concentration of the base is greater than the concentration of the acid. So when the pH is greater than our pKa, it must be true that the concentration of the base is greater than the concentration of the acid.